Hello friends, myself Dr. Akhilesh. In this video, I will discuss the important MCQs on osmolarity and osmolality. So this topic is important from the various entrance examination point of view like NIT PG, NEXT, INICET, FMGE, USMLE. So let us look at the questions here. So the first question is osmolarity is defined as. So in this question you have to know what is osmolarity, and you also have to know what is osmolality, and you also have to know what is the normality. So osmolarity. So osmolarity is, it is the number of osmoles per liter of the solution. So here you have to remember, number one thing is it is the number of osmoles, number two thing the liter, and the third one is the solution. So osmolarity is number of osmoles per liter of solution. The second definition is the osmolality. Osmolality is number of osmoles per kg of solvent. So here you have to focus on the kg, and the other thing you have to focus is the solvent. So osmolality is number of osmoles per kg of the solvent. Now the third definition is normality. So what is the normality? So normality is number of gram equivalents. So here you have to remember the gram equivalents. So number of gram equivalents per liter of solution. So these are the three definitions which you have to remember. Osmolarity, per liter of solution; osmolality, number of osmoles per kg of solvent; normality, number of gram equivalents per liter of solution. So now come to the question here. So in the question is osmolarity is defined as. So what will be the answer here? So answer will be the A, that is the number of osmoles per liter of solution. It will be the osmolarity. The option C, which is the number of gram equivalents per liter of solution, so it will be the normality. And the option D, number of osmoles per kg of solvent, so it will be the osmolality. So in this question we have been asked that osmolarity is defined as. So the correct answer will be the A, number of osmoles per liter of solution. Now let us look at the another question. The another question is osmolality is better than osmolarity for expressing the concentration of fluid because osmolality is. So we have to tell why the osmolality is better than osmolarity. So for this answer we again have to go to the definition. So in the definition, osmolarity is number of osmoles per liter of solution. So liter is the unit of volume. So it is the unit of the volume, and we know very well that the volume, it will change with temperature. So volume, the value of the volume will change with temperature. So therefore the value of the osmolarity, it will change with the temperature. Now the definition of osmolality. Osmolality is number of osmoles per kg of solvent. So here it is a kg of solvent, and the kg is the unit of mass. And we know very well that the mass does not change with temperature. So mass does not change with temperature. So therefore the osmolality will be better than osmolarity because its value does not change with the temperature. So let us come to the question here. So in the question, the osmolality is better than osmolarity because osmolality is, so answer will be the C, not affected by temperature of the solution. So the value of the osmolality does not does not change, or they are not affected by the temperature of solution. So therefore osmolality is better than osmolarity. Now let us look at the another question here. So in this question, the question is the normal range of plasma osmolality. So we have to tell the normal range of plasma osmolality in milliosmoles per liter. So remember this, that the value of this, the plasma osmolality, so this value is equals to 280 to 295 milliosmoles per kg of water, per kg of the water. And we can also write here, instead of milliosmoles per kg of water, we can also write here milliosmoles per liter of water. So we can replace the kg with the liter, because we know that 1 kg water is equals to 1 liter of the water. So instead of kg of water, we can replace it with the liter of the water. So therefore, the normal range of the plasma osmolality will be 280 to 295 milliosmoles per kg of water, or milliosmoles per liter of the water. So now let us look at the options here. So option A is 280 to 295 milliosmoles per liter. So this is the correct answer here. In the Harrison, so in the Harrison, it is also mentioned that the plasma osmolality. So in the Harrison, it is mentioned that the plasma osmolality is equals to 275 to 295 milliosmoles per kg serum water. So this value is mentioned in the Harrison. So you can remember this value also, which is mentioned in the Harrison. So in this question, the option A is 280 to 295 milliosmoles per liter. So this will be the correct answer here. Now let us look at the another question here. The maximum contribution of plasma osmolality is by. So in this question, we have to tell, or we have to know that which one contribute maximum to the plasma osmolality. So for this one, I have just told you that the plasma osmolality is. So I have told you that the plasma osmolality, this is equals to 280 to 295 milliosmoles per kg, or milliosmoles per liter of the water. So out of this 280 to 295, the sodium ion, chloride ion and bicarbonate, they contribute 270 milliosmoles per liter. So out of this 280 to 295, the 270 is contributed by sodium, chloride and the bicarbonate. So majority is contributed by sodium, chloride and bicarbonate. Now out of the sodium, chloride and bicarbonate, sodium ion concentration is more than the concentration of chloride and bicarbonate. So concentration of this sodium ion is more than the concentration of the chloride ion, and which is more than the concentration of this bicarbonate ion. So out of these three, the sodium ion will contribute maximum to this plasma osmolality. And the plasma proteins, they contribute less than 2 milliosmoles per liter. The glucose and urea, they contribute 5 milliosmoles per liter. So therefore, the maximum contribution of plasma osmolality is by sodium ion, because its concentration is highest as compared to the other ions. So there is a formula for the osmolality of the plasma, which is calculated by. So this, the osmolality of the plasma in milliosmoles per liter is equal to twice the concentration of sodium in milliequivalent per liter plus 0.055 concentration of glucose in milligram per deciliter plus 0.36 concentration of blood urea nitrogen in milligram per deciliter. So this, in this formula, The plasma osmolality depends upon number one thing, the sodium, number two thing, the glucose, and the number three thing is the blood urea nitrogen. So BUN is blood urea nitrogen, BUN. This formula can also be written as twice the concentration of sodium in milliequivalent per liter plus concentration of glucose in milligram per deciliter divided by 18. So if we divide it by 18, it will give the same value 0.055 into glucose plus urea in milligram per deciliter divided by 2.8. So if we divide the concentration of urea by 2.8, it will give the same value of 0.36. So this osmolarity of plasma is calculated by this formula. So this formula you have to remember because this formula directly comes in the exam, or the value will be given of sodium, glucose and BUN, and you may be asked to calculate the plasma osmolality. So osmolality of the plasma in milliosmoles per liter, or you can also say that milliosmoles per kg of the water is equal to, so remember this, twice sodium plus 0.055 glucose plus 0.36 BUN, or twice sodium plus glucose divided by 18 plus concentration of urea divided by 2.8. So now come to this question again. So maximum contribution of the plasma osmolality is Y. So answer will be the C, sodium. Now let us look at the another question. So another question is, so if you calculate the plasma osmolality of a child with sodium whose value is 125 milliequivalent per liter, glucose whose value is 108 milligram per deciliter, and blood urea nitrogen whose value is 140 milligram per deciliter, the most appropriate answer would be. So in this question, what is given here, that we have to find the plasma osmolality, number one thing, and what is given here, sodium value is given, the glucose, plasma glucose value is given, and the blood urea nitrogen value is also given. So these three are given, sodium, glucose and the blood urea nitrogen, these three values are given, and on the basis of these three values we have to calculate the plasma osmolality. So this is based on the explanation of the previous question which I have told you, that the plasma osmolality, so osmolality of the plasma in milliosmoles per liter or milliosmoles per kg, it will be equal to twice the concentration of sodium in milliequivalent per liter plus 0.055 concentration of glucose in milligram per deciliter plus 0.36 concentration of blood urea nitrogen in milligram per deciliter, or twice the concentration of sodium in milliequivalent per liter plus concentration of glucose in milligram per deciliter divided by 18 plus concentration of urea in milligram per deciliter divided by 2.8. So if we put the value of the sodium, the value of the sodium given is 125 milliequivalent per liter, and if you put the value of the glucose value given is 108 milligram per deciliter, plus if you put the value of the blood urea nitrogen whose value given is 140 milligram per deciliter. So if they put the value of sodium, glucose and BUN in this formula, so we will get the plasma osmolality of 306.34 milliosmoles per liter or milliosmoles per kg of water. So now let us come to the question here. So if we calculate this plasma osmolality, so its value will be, so answer will be the B, 363 milliosmoles per kg. So 306 milliosmoles per kg, this will be the correct answer. If we put this value of sodium, glucose and BUN in the formula, so we will get the plasma osmolality value as the 306 milliosmoles per kg or per liter. Now let us look at the next question. The next question is, which of the following is an isotonic fluid? So in this question we have to tell about the fluids which are isotonic fluids. So isotonic fluid means those fluids whose osmolality, is equal to that of the plasma, equal to that of the plasma. So fluids having osmolality equal to the plasma. So these fluids are called as the isotonic fluids. And what are the examples of the isotonic fluids? So examples of the isotonic fluids. So isotonic fluids having the same osmolality or osmotic pressure as that of the plasma. So example of isotonic fluids, they are, one is 0.9% NaCl, other example is 5% glucose, or you can also say that 5% dextrose. The third one is 10% mannitol, and the fourth one is 20% urea. So these are some examples of the isotonic fluids. So in the isotonic fluid, when a cell is kept, so cell will neither shrink or swell. So means the cells will not shrink or they will not swell. That is, they will maintain their shape in this isotonic fluid. So these are examples of isotonic fluid. And what are the hypertonic fluids or hypertonic solutions? So hypertonic means the concentration or tonicity is lower than the isotonic fluids. So for example, so let us take the example of this hypertonic fluid. So for example, 0.9% NaCl is isotonic. So the concentration is less than 0.9. For example, if the concentration is 0.2% NaCl, so this will become what? Hypertonic. Or 0.3% or 0.4%, means it should be less than 0.9% NaCl. So it will be the hypotonic. Or other examples is, if the concentration of this dextrose is less than 5%, again it will be the hypotonic. If the concentration of the mannitol is less than 10%, again it will be hypertonic. So hypertonic means the concentration is lower than the isotonic value. And if we put the cell in the hypotonic solution, so what will happen here is, the water will move from the solution into the cell and the cell will swell up. So this cell will swell up. So cells will swell in the hypotonic solution. Then what are the hypertonic solutions? Hypertonic solutions are those solutions whose concentration or tonicity is higher than the isotonic fluids. And here if we put the cells in the hypertonic solution, so what will happen is, the water will move out from the cells and the cells will shrink. So cells will shrink if they are kept in the hypertonic solution. So if the example of the hypertonic solution, if the concentration is more than 0.9% NaCl, so it will become hypertonic. If the concentration is more than 5% dextrose, it will become hypertonic. If the concentration is more than 10% mannitol, so again it will become what? Hypertonic. And if the concentration is more than 20% urea, again it will become hypertonic. So now let us come to the question again. So which of the following is an isotonic fluid? So here this 3% NaCl. So this 3% NaCl is, so this concentration is more than 0.9% NaCl. So this 3% NaCl is what? So it is hypertonic. So it is hypertonic solution. 20% mannitol. So this 20% mannitol is more than 10% mannitol. So again it is hypertonic. So it is again hypertonic fluid. 5% dextrose. So 5% dextrose is isotonic isotonic fluid. So answer will be the C, because it has been asked about the isotonic fluid. 0.09% NaCl. So this concentration is less than 0.9% NaCl. So this fluid, it will become hypotonic. So it will become the hypertonic solution. So which of the following is an isotonic fluid? So answer will be the C, that is 5% dextrose. Now let us look at the another question. So another question is 10% dextrose is. So I have told in the previous question that the 5% dextrose, this one is isotonic. So 5% dextrose is isotonic. So here it is given at 10% dextrose. So therefore the concentration of this 10% dextrose, its concentration is more than the concentration of 5% dextrose. So this will become what? So its concentration is more, so it will become hypertonic. So answer here will be the hypertonic. So answer is C, hypertonic. Now let us look at the next question. The next question is, which of the following is hypertonic fluid? So we have to tell about the hypertonic fluid, means the concentration will be more than the concentration of isotonic fluid. So 5% dextrose, so 5% dextrose is isotonic fluid. 0.9% NaCl, this is again the isotonic fluid. 20% mannitol. So this 20% mannitol, this concentration is more than the 10% mannitol, because 10% mannitol is isotonic. So 20% mannitol will be, this will be the hypertonic fluid, because its concentration is more than the 10% mannitol. So it is the hypertonic fluid. So answer here is C, 20% mannitol. 20% urea, again it is the isotonic fluid. So in this question, which of the following is hypertonic fluids? Our answer will be C, 20% mannitol. So this will be the correct answer here. So you can visit the Facebook page Physiology MCQ for more MCQs based on this physiology for various entrance exams. And you can also go through the book Conceptual Physiology Review, which you can order from the Amazon. So in this book there are a lot of questions based on the FMG, NEXT, INI-CET and various other entrance exams. You can order this book from the Amazon. So thank you very much for watching this video. If you have any comment, any suggestion, then you can send it to me in the comment box. And if you like this video, then you can subscribe it also. So thank you very much.